Hello students, how are you all? Welcome to the second part of electricity. In first part we discussed what is called current and then what is called potential and potential difference. If you missed that video, the link of that video is there in the description box. You must check that. So in the second part, mainly we'll discuss about Ohm's law. It's a very important law in electricity. In Ohm's law, the scientist Ohm said that the potential difference is directly proportional to the amount of current. Let me draw it, you will understand it better. We'll take a simple circuit. We'll take a bulb. The bulb will connect by wire with a cell or a battery. See, this is a bulb. I'm connecting this bulb with wire with a cell. Correct? This is my cell and this is my battery which is connected by wires. Now, as I told you, the battery or the cells has got a potential difference. We discussed in the first part. Let the potential difference of this cell is V. Got it? This V is the potential difference of this cell. And how much current is passing through this circuit? Say, I is the amount of current which is passing through this circuit. Now, Ohm said that if you increase this potential difference of the cell, I mean, instead of connecting one cell, if you connect more cells, like 2 cells, 3 cells, 4 cells, so instead of connecting one cell, if you increase the number of cells, means you are increasing potential difference. And if you increase potential difference, then more current will pass. You got my point? If you increase potential difference, then current will also increase. And if you decrease potential difference, instead of connecting 5 battery, if you connect only 3 battery or 2 battery, obviously the potential difference will decrease. And when the potential difference will decrease, amount of current will also decrease. So when potential difference decreases, current will also decrease. This idea was given by scientist Ohm. So he said that, means according to Ohm's law, the potential difference of a circuit is directly proportional to the amount of current passing through that circuit. Okay, I repeat. The potential difference of a circuit is directly proportional to the amount of current passing through that circuit. But before this, you have to add one sentence, at constant temperature. Yes, when the whole temperature remains same, only that case this law is applicable. Okay, if you are changing temperature, then the law, the value will also change. So what is the whole law? The whole statement is at constant temperature, the potential difference of a circuit is directly proportional to the amount of current passing through that circuit. So he said that V proportional to I. Got it? V is proportional to I. We know that when we change proportional sign into equal sign, we get a constant. So V equal I. So one constant will come. Say K is the constant. Okay? But here he said that this constant, he has given a special name to that constant. The special name is resistance. Yes. Now what is resistance? Resistance is something which opposes the flowing of electric current. I will give you an example. Say I have taken 2 wires. One is copper wire, another is say plastic wire, simple plastic. This is copper wire and say this is plastic wire. Fine. Now, if I say you through which wire current can pass? Through copper wire current can pass? Yes. Through plastic wire. Can you pass electricity, current? No. Why? Because of its resistance. Because plastic's resistance is much higher. That's why electricity cannot pass. Because resistance is something which always opposes the flowing of electric current. Resistance does not allow electricity to pass through. But copper has also resistance, but the resistance of copper is less. That's why current can easily pass. So you understood what is called resistance? Resistance is something which opposes the flowing of electric current. Yes. So he said that this constant is resistance. That's why we will not write here K, we'll write here R. R for resistance. So R. Got it? Now, so according to Ohm's law, potential difference is directly proportional to the current, and V equal to R into I will tell it V equal to IR. Okay, so I am going to rewrite this equation. Directly we'll say V equal to IR. Simple. Fine. Now say we are in the physics lab. Fine. And I'm asking you that how will you measure the potential difference of this cell? Yeah, you have to measure the potential difference. And also I'm saying you have to measure the amount of current passing through this circuit. So two things you have to find: potential difference and amount of current. Now to measure all this, we require two different devices. The first device we called voltmeter. Yes, voltmeter is the device by which we measure the potential difference. And to measure current, we will use ammeter. Now let us see how to connect them. See here, I am connecting a voltmeter. This is voltmeter. Okay. Now I'll connect an ammeter. To connect ammeter, I have to disconnect from here, and this is the ammeter. Okay. So in this way I have to connect voltmeter and ammeter. Now see, the voltmeter is connected parallelly with the circuit. Yes, you have to connect parallelly with the circuit, and ammeter is in series. So it's a very important question for you, that how should you connect the voltmeter in parallel and how you connect ammeter in series. Understood? Now, after finding this potential difference and current, if I say you draw a graph for this to show the relation between potential difference and current, yeah, we'll discuss the graph now. Now, if you draw the graph, you will see that, say this is my graph. Here I am going to plot potential difference, and here we are plotting current. Now potential difference and current we are plotting. In that case, if you plot the values of all this, you will get a complete straight line. Yes, this is the straight line you will get. Fine. Say the temperature is, the room temperature is 25 degree. So at 25 degree, you are getting this straight line. But if you increase the temperature, say from 25, the temperature is say 35 degree. At 35 degree, you will get a graph of this way. Yeah, little this side. Say it is 35 degree. If the temperature is less, say 20 degree, then you will get your graph of this way, 20 degree. Understood? So it depends on temperature. I told you before, according to Ohm's law, the potential difference is directly proportional to the amount of current. Yes, at constant temperature, when the temperature is same, so at this temperature you are going, this When you are increasing the temperature, you will see that the graph is being shifted this side, and when the temperature is less, then graph will shifting this side. Got it? Thank you.